Hey there, Assalamu alaikum. This is Dr. Ashik Yusuf, and today I am here to discuss one of the most important concept of class 11th CBSE chemistry. That's actually limiting reagent. Limiting reagent. What actually limiting reagent is? Let's start with the definition of the limiting reagent. A limiting reagent is one. It is one which consumes itself completely during a chemical reaction. So we can say that it is one in a given chemical reaction which consumes itself completely. Let's go for the example in order to explain it properly. Say I have got A reactant and I have got B reactant. If A and B combines with each other, obviously they give us product AB. Definitely they give us product what? AB. If A reacts 50% with B and at that time B reacts 100% with what? A. Suppose say at time t. Let's suppose at time t. When A was consumed itself 50%, at that time means that at which time? T time. At that time B was consumed itself 100% to give us what product? AB. So among them which one consumes itself completely? Obviously B consumes itself completely. If B consumes itself completely to form a product, so we can say that this B is called as the limiting reagent. This B is called as what? Limiting reagent. Now, how to discuss this limiting reagent in various numericals? How to calculate, how to recognize, how to determine the limiting reagent. Let's go for some example. Let us suppose we have a numerical. Find limiting reagent when 1 gram of H2 combines with 1 gram of Cl2. See, in this numerical, we have some given data. We have 1 gram of H2 and we have 1 gram of Cl2. So, in order to find out the limiting reagent, let's first of all write down the chemical reagent of this data. We have H2 and it reacts with the Cl2 and they both gives us HCl. They both gives us what? HCl. This is the chemical reaction for this numerical. Okay. I just write down the chemical reaction of this numerical in order to find out the limiting reagent. Next, what we have to do is simply balance the chemical reaction. For balancing of chemical reaction, as you can see here, we have hydrogen 2 times. Over here we have hydrogen only 1 time. So make it 2 times. So here in the right hand side we have hydrogen 2 times and in the right hand side we have chlorine 2 times, and we can say that now it is a balanced chemical reaction because left hand side atoms and right hand side atoms are now equal. Okay, this is our balanced chemical reaction. Next, in the given we have hydrogen 1 gram and chlorine 1 gram. Again we cannot say which one is the limiting reagent. So, in order to find out the limiting reagent in such type of numericals, simply we have to remember a rule. Or we can say that we have to remember a formula. What that formula is? That simply number of moles and stoichiometric ratio. First of all, we need to calculate the number of moles. So, for H2 molecule, how to calculate the number of moles? Simply, we have a formula, number of moles, that's N, which is equal to given mass divided by molar mass. And number of moles for H2. Number of moles for what? H2. It's equal to given moles of number of moles of H2. It's equal to given mass of H2, given mass of what? H2, okay ji, and molar mass of what? H2. You must know about the molar mass of each and every element, okay. Now, given mass of H2 is 1, given mass of H2 is 1, so we have 1 gram of H2 in given, okay. Next, what's the molar mass of H2? Simply, you have to multiply the atomic mass into atomicity, which is 2, that's equal 2 ones are 2, so we get the molar mass 2 gram. So divide this given mass with the 2 gram molar mass of what? H2. Given mass divided by molar mass. Gram cancel, it's equal to 1 divided by 2. So here, number of moles for H2 is equal to 1 by 2. Next, what we have to calculate? We have to calculate the number of moles for what? Cl2. Now, number of moles for Cl2. Number of moles for Cl2 is equal to given mass of Cl2, to that of the molar mass of Cl2, molar mass of Cl2. You need to also remember the molar mass of chlorine as well in order to find out the number of moles. Fine. Now, given mass of Cl2 is 1 gram again, 1 gram again. Now, what is the molar mass of Cl2? Simply, molar mass of Cl2. First of all, you must know the atomic mass of Cl. The atomic mass of Cl is 35.5. Fine. Now, multiply it with the atomicity 2. Here we have atomicity 2. Now, total molar mass of this chlorine molecule is equal to 71 grams. 35.5 multiplied by 2 is equal to 71 gram. So over here it is 71 gram. It is here what? 71 gram. Now this gram cancel. This gram cancel, and we get a value. It's equal to what? It's equal to 1 divided by 71. 1 divided by 71. Okay. Now, see here. We have number of moles of H2. It is equal to 1 by 2. Over here, we have number of moles of what? Number of moles of chlorine molecule. It is equal to what? 1 by 72. Now, go for this formula. Now, number of moles to that of the stoichiometric coefficient of what? Of H2. It's equal to what? Number of moles for H2 is 1 by 2. It's 1 divided by 2. Okay. Whole divided by stoichiometric coefficient. This is the stoichiometric coefficient. Here we have 1 times hydrogen molecule. Here we have 1 times chlorine molecule. So we have this stoichiometric coefficient. One is the stoichiometric coefficient of H2, and this one is the stoichiometric coefficient of Cl2. Okay. Now 1 by 2 is the number of mole, and 1 is the stoichiometric of H2. So over here we have 1, which is again equal. When we calculate this, so it is 1 divided by 2. This will give us the ratio of number of moles to that of what? Stoichiometric coefficient of H2. Now similarly calculate the number of moles to that of the stoichiometric coefficient of Cl2. Similarly, we can calculate the number of moles to that of the stoichiometric coefficient of what? Cl2. So we get what? 1 over 71. To that of the stoichiometric coefficient for Cl2 is what? Cl2 is what? 1. So we have 1 stoichiometric coefficient of what? Cl2. So write down 1 over here. So when we calculate this, it's equal to 1 over 71. 1 divided by 71. 1 over 71. Now we have both N of SC of H2 and N upon SC of Cl2. We have both values. We have 1 over 2. We have 1 by 2 of H2, and we have 1 by 71 of what? Cl2. Now, which one is the limiting reagent? That one is the limiting reagent. Whose value is less? Now, decide which one is limiting reagent. Obviously, this will our limiting reagent, because among them, this value is least. Whose value is least? Numerically, whose value is least? That is considered as our limiting reagent. So, limiting reagent is one whose number of moles and stoichiometric coefficient is less. Definition point of view, as we have already mentioned, It is one which consumes itself completely during a chemical reaction. But numerically, how to calculate, how to find out, how to determine the limiting reagent, simply you have to follow this ratio. You have to follow this ratio. And if the ratio of any reactant is low, if this ratio for any reactant is low, that reactant will be called as the limiting reagent. Okay, so this was all.